Hi guys, welcome back. We are going to hop into section 1.5, which is another one of our exponent rules. These are two special exponent rules. It's called the zero and the negative exponents. So, if we look at these, 3 to the 5th over 3 to the 5th. Well, we know like 3 over 3 equals 1, 4 over 4 equals 1, right? So we know that 3 to the 5th over 3 to the 5th does in fact equal 1 because it's the same number over the same number, okay? But I want to look at this as 3 to the 5th over 3 to the 5th, okay? And use our quotient rule. So earlier in this chapter, we did the quotient rule, and that said when we had the same base, which we do, 3 and 3, we subtracted our exponents. So this would be 3 to the 5 minus 5. Now we know that 5 minus 5 is 0, right? So in order for 3 to the 5th over 3 to the 5th to equal 1, and for 3 to the 5th over 3 to the 5th to equal 3 to the 0, 3 to the 5th over 3 to the 5th must equal 1, and so must 3 to the 0. So whenever we have something to the 0 power, that entire thing turns to 1. Okay, so it actually equals 1 whole. And that's so that way when we do something this way and we do something this way, we both get the same answer. Okay, so that kind of trips students up sometimes. So let's do some practice. So if we have 4 to the 0, that's 1. Doesn't matter what the base number is, that whole thing is 1. Okay, 1,000 to 0, that's also 1. Okay, what do you think x to the 0 would be? It's 1. Even though it's a variable, even though we have no idea what x is, because it's to the 0 power, we already know that it's 1. Okay, we won't deal with 0 to the 0. That's a very special case, and that's something you'll learn about later in mathematics. Okay, so there'll be no zeros to the zeros. Okay, so this is the general rule that anytime we have something to the 0 power, it is equal to 1, and that base number just can't be 0. Okay, so let's practice combining some things. So we have 7 to the 3rd times 7 to the 0. Well, 7 to the 0, that entire thing becomes 1. So now I have 7 to the 3rd to the 1, so that's just 7 to the 3rd. Okay, now this one, there is always this problem on the test. So I would strongly recommend starring that on our notes and studying it for the test. Maybe you even need to write study on it. There's always a question exactly like this on the test, okay? And everyone always struggles with it. Okay? So when I do this, I see 3 chunks being multiplied together. So I'm going to deal with each one of those. Well, 1 times 10 squared is just 10 squared. Plus 10 to the 1 is just 10, so 2 times 10 is all that's left there. And then 10 to the 0 just becomes 1, so that's just 3 to the 1. Or 3 times 1, I should say. Okay? So all I did was look at all of these exponents and its multiplication and see what I would get. Okay? Now 10 squared is really 100. 2 times 10 is 20, and 3 times 1 is 3. So 100 plus 3 is 123. Okay? So I just took my time and came up with an answer there, so that way I could simplify that problem, okay? So again, that question always comes up on the test, so make sure you start it so that way you remember to study it, okay? Now this problem here, I'm just going to rewrite it. This is 4 squared times 4 to the 6th all over 4 to the 8th. So we're just combining some properties that we've been learning. So 4 squared times 4 to the 6th would be 4 to the 8th over 4 to the 8th. Which right here we know is 1, or we could say it's 4 to the 0, and we know that 4 to the 0 equals 1, and that's because 8 minus 8 is in fact 0, and anything to the 0 power is 1. Okay, so both of those examples use the fact that we get a 0 power answer, and we can go from there. Go ahead and try this one here. Okay, so as soon as I see a to the 0, I know that equals 1, so I have a to the 4th divided by 1. Times a to the 3rd, and a to the 4th divided by 1 is just a to the 4th. So this is the same as a to the 4th times a to the 3rd. And when I multiply my bases, that means I add my exponents, so I have a to the 7th. Okay? Go ahead and try this one for yourself as well. So this would be 5 to the 3rd times 5 to the 6th all over 5 to the 9th. This would be 5 to the 9th over 5 to the 9th, which we know is 1 right away. But if we need to use our quotient rule, we can. 9 minus 9 is in fact 0, and 5 to the 0 is 1. How exciting is that? And I believe this is day 2, so we're going to talk about that tomorrow. Have a wonderful day, and we'll talk to you later. Bye.